Dear students, good morning. In this video, we are going to see about what is the function of PLC and its softwares and PLC programming. Okay, we are going to see about that. What is the functional block diagram of PLC and its working principle? We are going to see first. So, if we are going to see about the PLC, we are very familiar about the controllers. For example, Arduino ESP32, we are very familiar about these controllers. We are going to use that for our project work. We may done for small mini project or even medium level projects. If you are going to do for the real industrial solution, we may not suitable to go with it ESP32 or Node MCU. We have to select the only controllers, programmable logic controllers. We can expand the or increase more number of I/O ports. We can able to connect and control more number of I/O ports. Then we have to choose the programmable logic controllers. Here ultimate thing is we are going to take for that PLC for any. This is actually programmable logic controller. Based on that program given to the controller will able to do that performance, that is able to do that or controlling the output device connected to the system, that is controller. The input side is we are going to use for that various type of input devices. So we are going to see about that the basic PLC. Okay, this is actually block diagram of PLC. We are going to see here the major components is input device. The input device is mostly sensors and switches. In that output device, we can say that the input model is all the input device, that is sensors or switches connected through the input model to the programmable logic control, that is central processing unit. Then again the output is connected with the output model, so that is called the load devices, motor, lamps, relay, everything. That is called the output device. We have to interface the programming device so that based on the setup coding, that is we have to write the program to control the output device based on the input sensor value. This is provided for both input side and output side optical isolation. So both input and output models are connected to the supply as well as require supply for the central processing units. We need to store the program through memory. The central processing unit is process the data. So the programming device is basically a laptop or system is connected. Based on our programming, whatever the program we have done, based on that input, what will be the output or how the output will be controlled, that will be taken care by the program. Based on the written program, setup instruction given through the PLC, the output devices are controlled. Okay. We are going to see about that these are the main parts we have already seen. What are the main parts means? Input model. The input model is used to connect various type of input devices. The output model is required to connect various output devices. Through the output model and input model, input output devices will be connected. Between the input output models, we are going to use it central processing unit in the PLC. For all the three models require power supply. The central processing unit is controlled through programming. We are going to see about the power supply model. The PLC may operate the voltage ranges specifically 24 voltage DC, 120 voltage AC or 240 voltage AC. It depends upon the system design and application. If you are going to use that PLC 24 volt DC, need a 24 volt DC power converter to operate the PLC. So these are representing the voltage value. For 24 voltage, we are going to take for the supply from 220 volt AC. It uses the 24 voltage DC. We definitely need a power converter from 220 volt AC to 24 volt DC. This structure is similar to the previous functional block. The central processing, we are going to see about the central processing unit. This is actually main part of the PLC. It processes all the instructions required for the working of the circuit. First, we have to write and store the program or the instruction in the memory. In the operation time, the CPU takes a command from the input module, then process and ultimately gives output to the output module. The common function of the CPU in a PLC system are program execution, data processing, communication, memory management, diagnostics and fault handling, real-time control, timing, synchronization, security and access control, etc. These are the functions are carried out through the CPU. It's actually CPU is the brain of the PLC that is executing the control program and managing the overall function. It is doing for the program execution whatever the program we have stored in the memory that will operate in a cyclic manner, that will process arithmetic and logical operations to determine the appropriate output action based upon the values getting from the inputs. That may be a user input or maybe a input from sensors, and that will also managing the memory management. Then that is also able to handle the input outputs. Similarly, for doing that communication, it manages the communication with other devices, HMI, human machine interface, SCADA systems, or communicate with other PLC using various protocols. Diagnostics and error handling, it monitors system health, defect faults, and initiate appropriate responses or alarms. Timing and synchronization is very important. The CPU maintains system timing, manages interrupts, and control time-dependent operation very precisely. Data logging, it can record operation data, events, and alarms for later analysis or troubleshooting. Memory, if you are going to use that memory, primary memory, that is random access, secondary memory, auxiliary memory. These are the memories required for operating the system in a faster manner. We need to store that whatever the program That way the processing will be takes place. We are going to take for the software in PLC. We have so far seen about the function of the PLC. What are the various major components present in the PLC we have seen so far. Now, what is software in PLC? We are writing the program for PLC functionality. So, in PLC, process software, often called executive software, is the internal program provided by the manufacturer that manages the PLC operation and executes the user program. So, executive software means it is an internal program provided by the manufacturer that manages the PLC operation and executes the user program. Okay, it is responsible for the fundamental operation of the device. It is actually pre-installed. So suitable for scanning the user program, especially for scanning the user program. Okay, this executive software managing input outputs, communication, error handling, real-time control, all the things will be taken care by the executive software. The second is PLC programming software. While we are going to execute the software is internal, users interact with the PLC through programming software. We are going to write for controlling one particular application. If we are going to control fan or light, we need to write the program. So that is nothing but programming software. That is external user operated, used to create and manage the user PLC program. That is the key difference. We cannot able to modify or change the executive software. Programming software, we have to write the own program for doing particular operation. So this is actually software in PLC. Example, we are going to see about the PLC programming software. Siemens, Rockwell, Schneider. Based on the brand, the software is varied. Mitsubishi, Omron, Delta, Coaches. Okay. We can do further multitasking functionality in PLC. Okay. Next, PLC programming language. We are going to see about that. We are going to write that program for the PLC. We may already familiar about that C program, C++, Java like that. If we are going to do that PLC, if we are going to take for Arduino or Node MCU, we may write for that program, Arduino program, and write the program and dump to the controller. That way we can able to perform particular operation or controlling the particular application. If you are going to take for the PLC programming language, there are 5 most common PLC programming languages. It is defined by the IEC 611313 standard, or ladder diagram is defined as LD, functional block diagram FBD, sequential function chat SFC, structured text ST, and instruction list IL. So these languages provide diverse approaches to programming PLC, catering to different needs and levels of expertise in industrial automation. So the same is represented here. Textual language and graphical language, these are the two major classifications in PLC. We are going to take for the textual language, instruction list and the structured text. Similarly for graphical, ladder diagram, functional block diagram, and sequential chart. This is we have to write the textual language. We need to give the instruction, or we have to write that. We have to type the instruction as a list or a structured text. This is actually graphical. We can use it for the diagrams, representing the diagram in a program in a diagrammatic manner, so that we can able to do the certain function using this PLC. Dear students who understood about the basic function of basic function block diagram of PLC software, then PLC programming languages. Hope you are familiar about these things in this video.